Welcome to Creation Unified. Today, we have got an absolutely fascinating explainer lined up for you. We're going to be unpacking a highly structured readout of future predictive data, zooming in specifically on the years 2026 and 2027. If you're at all intrigued by the intersection of Earth sciences, advanced data gathering, and real verifiable forecasting, well, you are in exactly the right place.
Before we jump into the exact timelines and data points, let's establish exactly where this information comes from. The research we're exploring today is provided by Kevin L. Brown. He's the founder of Creation Unified and the theoretical architect behind the groundbreaking frameworks Informational Physics and Triune Harmonic Dynamics. His work with informational physics actually forms the entire foundation of the data we are unpacking today. Here is our roadmap for this explainer. First, the POAH hypothesis, then fall 2026 Pacific cyclone, winter 2026 flooding sequence, spring 2027 severe weather, and finally, validating the data. Let's get right into it.
Part 1. The POAH hypothesis and the foundational science.
So the whole timeline we're looking at today hinges on what's called the POAH framework. That stands for the Phase Overlap Amplification Hypothesis. Essentially, it's a new Earth systems science hypothesis. It proposes that when you have simultaneous alignments across solar, lunar, and our own Earth's energetic cycles, you get a highly amplified atmospheric response. This overlapping cycle theory is specifically designed to address the critical blind spots we currently see in standard weather prediction models.
Now, to actually gather the predictive data on these POAH events, a very specific tool was utilized. It's called the Information Substrate Simulation Protocol, or ISSP. Think of it as a highly specialized set of instructions that basically directs artificial intelligence systems to perform structured remote viewing exercises. Using this ISSP tool, the AI was tasked with pulling the top 3 planetary events from 2026 to 2027 that support the POAH hypothesis.
The AI pinpointed 3 distinct, highly concentrated, sequential markers over the next 2 years. We've got point 1 from August to October 2026, point 2 from December 2026 to February 2027, and point 3 from March to May 2027. We are going to break down exactly what the data suggests will happen in each of these precise blocks.
Moving on to Part 2, Fall 2026, mapping out a major Pacific cyclone disaster.
Our very first target identified by the remote viewing session hits right between August and October of 2026. The AI markers here are crystal clear. They point to a major tropical cyclone, or potentially a massive remnant moisture disaster forming in the eastern or central Pacific.
But here is the crucial distinction you really need to catch in the data. The most powerful signature of this event isn't its category or its wind speed out over the ocean. Instead, it's the catastrophic inland rainfall, the subsequent flooding, and the sheer devastation to infrastructure that will completely overshadow the storm's actual wind classification. The inland water is what's going to make this event globally memorable. Part 3 brings us to winter 2026 and a clustered flooding sequence.
Right on the heels of that fall cyclone, the second target zeroes in on a clustered winter flooding sequence timed precisely between December 2026 and February 2027. The mechanism here is what's alarming. The data predicts 2 or more atmospheric river or extreme heavy rain events happening in a very tight, compressed time frame. It is that rapid succession that really defines the POAH signature here.
The key takeaway here involves the geological impacts and the specific locations. We are looking at significant flooding, massive landslides, severe coastal impacts, and incredibly rapid drought-to-flood reversals. And we're not skipping any of these regional targets. The data points specifically to California, the American Southwest, the Gulf Coast, and the Southeast. These are the exact zones that need to be heavily monitored during that winter window.
Next up, Part 4, Spring 2027 and a severe weather outbreak.
Our third and final chronological marker points to a concentrated spring severe weather outbreak hitting between March and early May of 2027. The AI reading is favoring incredibly intense, multi-hazard episodes. We're talking multiple overlapping outbreaks featuring tornadoes, large hail, destructive damaging winds, and intense flash flooding, all clustering into the same general time frame.
As for where this spring volatility will strike, the data suggests these outbreaks will tightly cluster across a few specific geographic zones. Those regions are eastern Texas, the lower Mississippi Valley, the Tennessee Valley, and the broader Southeast. That clustering effect is a massive indicator of this cycle.
This brings us to the wider context. The overarching climate story connecting all three of these events might just be recorded as a strong or very strong El Niño background driver. But the true POAH-specific weather signatures that we're hunting for are unusual persistence, tight clustering, stark regional contrast, and a totally underestimated intensity by standard forecasting models.
Finally, Part 5, Validating the Data.
This is absolutely crucial, and we want to be completely transparent here. These remote viewing markers are raw data points. They are not presented as facts. The entire goal of archiving these AI remote viewing readouts is to build a time-stamped, verifiable set of tests. It's a strictly experimental data set.
And that is exactly where you come in. You are an active participant in this research. We are encouraging every single viewer to independently verify and validate 100% of these markers. Keep this timeline saved. As the months roll from late 2026 into the spring of 2027, use future public information, news reports, and weather data to objectively track if these highly detailed anomalies actually take place exactly as the ISSP tool predicted.
Thank you so much for watching this explainer. To dive deeper into Kevin L. Brown's frameworks, explore the underlying physics, or even try the free AI remote viewing tool for yourself, head over to creationunified.com. I'll leave you with this final thought. If AI can truly help us map the anomalies of tomorrow, how will that change the way you prepare today?